Hi guys, this is Miss Hale, and these are your fiber notes for the hair and fiber unit. Remember that we're looking at how can hair and fibers implicate a certain suspect in a crime. So how can we use fibers, in this case, to point to a certain suspect of being in a crime? And so how forensic scientists use fibers, they evaluate them, so they test them to show what type of fiber it is, what the color is, if there's violence, so is there blood on the fibers, the location of the suspects, where they were, and the point of origin of the fiber. Where did it come from originally? And this could be from a house or originally even further back from the factory. So when you sample and test a fiber, there's a few different things that you're going to look at. The first is that fiber transfer is usually through shedding. So this means that the carpet or the clothing, usually a sweater, will have fibers come off of it. And microscopes reveal shapes and characteristics and markings on the fibers. You can also use infrared spectroscopy, which uses the chemical structure of the fiber to see if they're similar, to try to match the fibers together. And you can also use destructive testing methods to test for different fibers. You can burn them. You can also try to dissolve them in different liquids. And we'll actually be doing that next class. And so you might have a burn analysis key, and you'll compare the fibers found on different suspects to those found at the crime scene. And there's lots of different kinds of fibers, so we're going to be testing them to try to match them together. And one type of fiber is natural fibers, and there's three groups within natural fibers. The first is animal fibers, meaning that the fiber is made of proteins. This includes wool and cashmere from sheep, mohair from goats, angora from rabbits. It can also be hair from alpacas, llamas, or camels, as well as silk, because this is from caterpillar cocoons. And silk is interesting because it's really not going to shed very many fibers. And if you think of silk, you can see why that would be true. Plant fibers is the next type of natural fiber. Some properties of plant fibers is that they absorb water, but they're also insoluble in water, meaning they don't dissolve. They're very resistant to damage from harsh chemicals. They're dissolved only by strong acids, but they can become very brittle over a long period of time. So some common plant fibers, the most common is cotton, and this is actually a picture of cotton here. You can use the hair on the outside of coconuts. Hemp, jute, and flax from stems, those are all 5 different plant fibers. And manila and sisal from leaves are plant fibers as well. If you think of like a manila folder, that would be like manila. And then the last type of natural fiber is a mineral fiber. Fiberglass is a natural fiber. Sometimes you'll use fiberglass to make a lightweight car or a lightweight boat. You can also find it in insulation. And then asbestos, which is something you might have heard of before, is actually a fiber that doesn't burn. And so it was used a lot in construction in the 50s and 60s, and then they found out it causes cancer. So now if you have asbestos in your house and you're going to be ripping it up, you need to have hazmat people come in with suits and all those kinds of things. So those are our natural fibers. And now we're moving on to synthetic fibers. About 50% of fabrics are artificial, so they are synthetic. And examples of those are rayon, acetate, it's kind of similar to silk, nylon, acrylic, and polyester. So here's some regenerated fibers, meaning that they use cellulose, but then they either heat them or melt them to make a new fiber. And so rayon is the most common. It imitates natural fibers, but it's really strong, and so you might use it. A lot of times you'll have rayon blends, and if you think of like gym short material, that's usually made of rayon. Celanese is found in carpets, and so this is when cellulose is chemically combined with something called acetate. And then polyamide nylon is used in performance clothing, so this is when you're going to have what you're going to have in like an Under Armour shirt. Then they have synthetic polymer fibers, which are different than synthetic cellulose fibers. They have a petroleum base. They're made from gasoline, or the same thing that gasoline is made from, excuse me. They're really different from other fibers, and so what they do is they'll take monomers and they'll join them all together and make a very long polymer. And if you took chemistry, that should sound familiar. Then they spin the fibers together into yarns. There's no internal structure in these fibers, and they're very, very uniform from how they're made. So some examples of this are polyester. This is what polar fleece is made out of, so if you think of fleece, as well as nylon is another type of synthetic polymer fiber. You can also have acrylic. Acrylic's very inexpensive. It's a nice substitute for artificial wool or fur. I have a sweater from when I was very little that's made totally of acrylic. And olefins are another fabric that's used in, a fiber that's used in high performance fabrics. So they're very quick drying and they don't wear very easily. And then here is, if you were looking under fibers under magnification, this would be a really good chart to use to help you do that. So here's the difference between yarns, fabrics, and textiles. Yarns are fibers of any length, thick, thin, loose, tight, that are twisted together. If you blend fibers, it meets different needs. So you might blend a rayon with a cotton to resist wrinkling or something of that nature. And then fibers are going to be woven into fabrics and textiles. Threads are arranged side by side. That's the warp. And then if they're going back and forth crosswise, that's the weft. So here's an example of some weave patterns. There's plain weave pattern. This is very firm. It wears well. It tends to wrinkle pretty easily though. There's a basket pattern. It has a very open weave. It doesn't wrinkle, but it's not very durable. And it tends to shrink when washed. The satin fiber is not durable at all. It tends to snag and to break during wear. If you've worn silk, you might know this, or satin. It's very shiny and it reflects light very well. And it doesn't really, there's not much friction. So if you think of satin, you can think of that. Twill is very strong. It's very dense, compact, and it has different designs on either surface, on either face of the fabric. And then a leno is an open weave. It can be very easily distorted, but it only stretches in one direction. And so those are the different weave patterns which are already in your notes guide. Those are your fiber notes. Please write down any questions that you might have and bring them with you to class tomorrow. Thanks, guys.